Hello, everybody. This is going to be the material that covers the week 5 review. This is Ms. De La Garza. The week 5 review is basically what we've covered in weeks 1 through 4. So that's why there's hints on the Google Classroom to do that. Let me share my screen here real quick. So if you go in here to the Google Classroom, oh yeah, and then I wanted to show y'all that right here is where you can get the TI calculator. It's at the top of each class period. So how to get a TI calculator, it's online. You can use desktop version, iPad. It tells you what to do for those and where to click and the codes that you need. So if you need an online calculator, try it out. If you cannot get that calculator, please let us know and we can maybe see about getting you another type of calculator. But that's the best way to get that calculator because it's free. You don't have to go anywhere to get it. It'll be right there on your computer. Okay, so if we go to week 5, that's why there's only one thing or one assignment. There's no lessons because it's all just review of what we did on weeks 1 through 4. So you have quite a few more questions here. You have 12 questions. The first part I'm going to go over is weeks, or excuse me, not weeks, numbers 1, 2, 3, 4, and then I'll go into the other ones. So I'm going through basically 1 through 4 right now. All right, let me switch this to my. Okay, so numbers 1 through 4, that's what we're going to start with. This is going over basically exponential and linear graphs. So let's do a review on exponential and linear graphs real quick. So exponential are the curvy graphs. They usually look like this, like this. And I'll do another one down here. Whoa. All right, so this is like a regular graph. A growth, an exponential growth will curve up. And what I mean by that is, remember that when you read graphs just like you would read a book. You read it left to right. So if your graph curves up like this, that is a growth. So if we go left to right, that graph is getting bigger. It's going up. A decay looks like this. It's going from left to right, it's going down. So this is a decay. And that's all you're doing for numbers 1 through 4 is just looking at the graph and saying, okay, is that a growth or a decay? Make sure you're looking at this line in particular or one of these lines. And then read the graph from left to right. When we talk about linear graphs, those are linear. And linear, once I write the word, you'll notice has the word line in it. Linear. Has the word line. It's not going to curve. It's going to be a straight line. So it should be like this. Or like this. No curves. Exponential have those curves in it, like this or like this. But linear will have those straight lines in it. So that's important to remember. Okay, so that's when you're just looking at a graph and you're just saying, oh, that's a linear graph. Oh, that's an exponential graph. Okay, so that's numbers 1 through 4. Let me go back to make sure I'm not missing anything. Now, number 5, 6, 7, and 8. Let's talk about what those represent. And really all they're asking you to do is just look at that equation and identify which equation it is. Is it a linear equation or is it an exponential equation? If it's an exponential equation, is that a growth or a decay? So that's what we're going to go through right now. Okay. So we have the exponential equation. And that can look like this. Or it can look like this. This one shows growth. So, or this is, I'm sorry, this is not growth. This is decay because of that subtraction sign. The other one is the growth. And really, growth. All of these, I think what freaks everybody out is that it's got a lot of letters. Don't freak out because of the letters. Okay, remember, variables, which are what the letters are called, variables just represent numbers that you don't know yet. You can always take those variables or those letters out and put numbers in their place to solve problems. But when you're looking at an exponential, it can look like this, this, or this. A linear equation looks like this. I'm going to write this again because I'll go back to that here. A linear equation is the one that we use a lot in algebra. It's the y equals mx plus b. Okay? So that's the difference between when you're looking at all these equations, which one is it? Is it exponential or is it linear? Remember that there's numbers that represent these. They just take the a out and put a number, or they take a b out and put a number. Or on the linear, they'll take the m out and put a number, or they'll take the b out and put a number. Okay, it's just, that's the way formulas work. All right, let's go back to the questions. I think it was like 5 through 8. 5 through 8. All right, so remember, if your equation looks a lot like this, this shows growth or decay. So the number that's in parentheses shows the growth or decay. Remember that it's a growth if the number is 1 or more. It's a decay if the number is between 0 and basically 99 cents. Because you got $1 here, 99 cents. So let me go over that. That was kind of ugly. Growth, if you're looking at this, if you're looking at B, if it's 1 or more, then it's a growth. If it's between 0 and 99 cents or 0.99, then it's a decay. And the way I like to think about this is with money. So let me give you an example. If we had y equals 3 times 1 to the x, this number is 1 or more. So this is a growth. If we had y equals 12 times 0.89, that's like saying 89 cents. So 89 cents is less than $1. So this is a decay. So you have to think about, I like to think about it like money because everybody knows money usually, so it's kind of easy to think of it like that. Now let's say the equation, this is the other exponential. If it's written like this, that's also exponential. So this is the growth because of this plus sign, and this is the decay because of that minus sign. So really you don't even have to solve anything. If you look at numbers 5 through 8 and you see a minus, then that's a decay. If you see a plus, then that's a growth. Well, let's give an example. If I have y equals 3, 1 minus 0.15, then this is telling you that it's a decay. The subtraction sign is telling you it's a decay. You could also solve it. 1 minus 0.15 is 0.85, and 85 cents is less than $1, so that's a decay. But you really don't even need to solve it because this minus sign right there tells you that it's a decay. All right. So hopefully that will help you on numbers. If it doesn't look, dang it, if it doesn't look like an exponential, then the only other thing it can be is linear. If you have an equation that's y equals 12x minus 2 or y equals 3x minus 1, that's, or let's see, these are all linear equations. So be careful. Remember, we have different equations. They all have their own formulas. So you need to know how they look. All right, moving on to number 9 is our word problem. And when we have our word problems like this, we're going to use the exponential formula. And we need to know, are we going to use y equals a1 minus r? Or are we going to use y equals a1 plus r? Whenever you have a word problem, these are the formulas that you're going to use. This is the exponential formula. Okay, so what you need to do is go on the word problem. Does it say there's a growth, or use words like growing, increasing? That means that it's a growth. But if it's using words like decreasing, decaying, getting small, anything that indicates that it's getting smaller, that's where we're going to use the decay. So I think in this problem, it talks about growth. Now, I'm not going to use the same numbers that they use in the problem, but I'm going to get one that's pretty close. So for the problem on number 9, they're talking about a growth. They use the word, I think, grows. Let me see. Let me go back to it. Yep, the town grows at an annual rate. So that tells you that you're going to use the growth formula. All right, so we're going to follow this formula. This number is your beginning value. So what's our beginning value? Well, I'm going to make up a word problem, but I'm still going to kind of use. Let's say the initial population starts at 40,000. So I would say y equals 40,000 because that's where the population is starting. Then I just do my 1 plus because that doesn't change. The R represents the rate. So in the fake problem I'm doing, let's say the rate of the population is growing by 2.3%. Well, we want to turn the rate as a decimal. So we have to take that 2.3%, and it already I know it already has a decimal, but that doesn't, that means we need to move the decimal to make it a true decimal. So we're going to take 2.3, we're going to move it over 1, 2, and we fill our hump with a 0. So this is 0.023 to the t power. And really, all this question is asking is that you write the formula. You're done. We don't really need to go any farther. If you did, you could do 1 plus 0.023 and get 1.023, and then multiply that by 40,000. The T represents some kind of time period. So they said the annual population was 40,000. It's growing at a rate of 2.3%. How much would the population be in 10 years? That 10 you could plug in right there and then put it in your calculator and it'll tell you what the population will be in 10 years. But we don't need to go that far because all this question was asking for was this. And then somebody in the Zoom earlier told me, what do you do with this T? How do you make it look like an exponent? In your calculator, or when you're answering questions on the Google form, if you want to do just Shift 6, that will give you that caret. And you can do like the caret symbol and T. We'll take that. But even if you didn't do that, if you just put 40,000, 1 plus 0.2 or 0.03, that still tells me that you're getting it. So please don't get bogged down with, things like that. It's forgivable. We know it's kind of weird when you do it in the Google Doc. Okay, so that was the word problem. Let's go over to 10 through 12. This is where everybody is getting stuck. And guys, I understand pretty much everybody's getting the box method, but if you're having very difficult time with the factoring, please let me know. I will get with you and we will work through it, or we'll figure something out, but I need to know that you're struggling with that. Okay, so let's do some examples. This is like what we did last week with the box method. So they gave you two factors, 2x, this is just an example, 2x minus 1, and then x plus 7. We're going to draw our box. And remember, it doesn't matter where you put them. It doesn't matter where you put them as long as they stay within the parentheses. So 2x minus 1 on top, they stayed together. X plus 7 on the side. So just as long as whatever's in the parentheses stays on the same side, you're good. What I get questions of is there's no number in front of this X. Just write in a 1 if you need to. Remember, in math, there's those invisible ones. It's supposed to be known that there's a 1 there. So if you need to, though, write it in, because sometimes your brain needs to see that number, and that's fine. Okay, remember that on the outside of the box, we're going to multiply. So for this square, we're going to do 2 times 1 is 2. We have x, and we had 2x's, 1, 2. So that's x squared. Then for this box, 1 times -1 is -1. So be careful when you're multiplying your negatives. Put it in the calculator if you need to. Then we're going to go to the next box. 2 times +7 is 14. And we have that x up here, so this just gets 1x. There was only 1 that time for this box. Then we have 7 times -1, so that gives you -7. Oops, I forgot my x. So let's go back here. I did 1 times -1, and it had this x here, so this gets an x. Okay, and that's important because 2x squared was the only x squared in that box, so it's going to stay the same. However, both of these are numbers with x's attached, so I can combine them. In the middle of the box, it looks like there's a plus sign, so that's why we're going to add them. 14 plus -1 is +13, and then that x is going to stay there. And then again, this -7 is kind of by itself. It has nothing to combine with, so it's -7. Now, I had the question of, well, why did this get x squared right here, but then down here this only got an x? Well, that's because we're multiplying on the outside. When you multiply exponents, you're actually adding them. So 1 plus 1 is 2. But when we're doing the middle, we're adding. So that means that the x's are just, they're alike. They're just going to stay with that number. Okay, let's do another example. Remember, you can always go and write the question from the graded assignment. Write it on a piece of paper. You can follow along with me. Remember, these problems are just alike. I'm just using different numbers. Let's do 3x minus 2, and then 4x minus 1. Draw my box. All right, so 3 times 4 is 12, and then x squared, because we have this x and this x. We're multiplying. When we multiply and we have exponents like this, we're actually going to add them. 4 times -2 is -8. And this has that x here, so that gets that x. 3 times -1, don't forget about that negative here, is -3, and we have this x up here, so that gets an x. And then -1 times -2 is +2. Negative times a negative is a positive. So again, there's nothing to combine with my x squared. I'm just going to leave it alone. I'm going to combine my like terms, -3 plus -8 is -11, and the x just hangs on, and then plus 2, because this is a +2. And we're done. All right, now there's another one on your, I don't know if it's 10 or 11, but it's going to turn out just a little bit different. I'm going to do an example of that one real quick. Let's say we have 2x minus 4, 2x plus 4. Okay, so again, we're going to do 2 times 2 is 4x squared. 2 times negative 4 is negative 8x. 2 times 4 is 8x. And 4 times negative 4 is negative 16. So we have 4x squared. But look what happens. We have 8 minus 8, or 8 plus negative 8. It's the same thing. 8 minus 8 is 0. So there's nothing there. So we don't write anything. We just add this negative 16 and we're done. So that one's a little bit different because this went away in the middle. It's 0. And in math, you don't need to write 0. If there's nothing there, there's nothing there. So that's why there's nothing in my answer. It disappeared. All I have is this 4x squared minus 16 and we're done. All right. Now, number 12, I believe, is the one that everybody's having a factor on. And remember, let's look at the problem that we just did. We came up with an answer, and it came out of having factors like this. Well, now, instead of going from this to this, we're going from this to this. That's what factoring is. So that's why on number 12, you're starting out with what looks like the answers we were getting. And you're working backwards to figure out those factors. And this one does have a lot of steps in it. That's why, you know, if you need help, I need to know. Especially if you watch this video and you're still having trouble, please let me know. Okay, so let's do the example. We have 4x squared minus 7x plus 3. Okay. So they gave you this quadratic, that's what it's called. Remember, this is what the quadratic formula kind of looks like. This is why we do factoring, because it's part of the quadratic equation. We label this first number A, this next number B, and this C, because the quadratic equation is ax squared plus bx plus c. But now they replaced the A, B, and C with numbers. So trying to give you a little background on what we're doing here. All right, so I need to get factors. I need to get those numbers that are in parentheses. So this is how we're going to do it. First, we're going to start with our eye chart. The number on top is A times C. So 4 times 3 is 12. 4 and 3, A and C. The number on the bottom is B, which is -7. Do not forget about this negative right here. So what goes in the middle? Remember, you have to figure out what two numbers multiply to 12 and add to -7. So the first thing, don't even worry about the negative right now. Let's just go through our multiplication factors. And this is the one where I said last week, it might help to get a multiplication chart if you're not very good with multiplication facts. And you can Google multiplication chart and a zillion will pop up. All right, so 1 times 12 is, of course, 12. But 1 plus 12 is 13. That won't work. We could try negatives. -1 minus 12, that's -13. You could do -1 plus 12. That's still 11. So you're not getting anywhere close. So you know that this won't work. 2 will go into 12, so we can try 2. 6 times 2 is 12. And 6 minus 2, it's never going to work. You're always going to end up -6 minus 2 is -8. It's just not going to work, whether you do negatives or positives. So then let's try, we know that 4 times 3 is 12. That's how we got to 12, right? So we know that, whoops, 4 times 3 equals 12. We know that 4 plus 3 equals 7, but we need it to be negative 7. So just turn them into negatives. Equals negative 7. So these are going to be our factors, negative 4 and negative 3. This is probably the hardest part because kids really struggle with their multiplication facts and adding and subtracting negatives if there is in fact a negative. So that's why that multiplication chart might help out. Okay, the next step is we're doing the box method, but in reverse. The number that goes in this box is 4x squared, this first box. Starting to look familiar? And then the next number in that last box is this plus 3. So again, you use A and C right here every time. And then we're going to stick our factors in. It won't work if negative 3 goes here because negative 3 isn't a factor of 4. It won't go into 4. So that's why I put negative 4 right here, because I know 4 will go into 4. Okay, earlier when we did the box method, there was always an x here and an x here. Whoops, I forgot my little x's here too. So now I can just work backwards. You know, and you could do 2 times 2, but when you get down here, it won't work. So I would start with my first. 1 times 4 is positive 4. Now, be careful. 4 times what gives you negative 4? That would be a negative 1. So just be careful with your negatives. So I have that top factor now. So I did 4 times 1 gives me 4 times 1 gives me 4. 4 times negative 1 gives me negative 4. Now I've got to go up here. 1 times negative 3 gives me negative 3. And negative 3 times negative 1 is positive 3. So that works out. So my factors are right here. X minus 1 or x minus 3. You can flip-flop those, but as long as that x minus 1 is in that parentheses and the 4x minus 3 is in its own parentheses, you're correct. Okay, and if you need more examples, I did a couple of these last week on the week 4 video. Now, if you are just struggling, I talked about this last week too. If you are just struggling with this factoring, remember, use your answer choices. So that's what I'm going to do right now. I'm going to use my answer choice and I'm going to give y'all an example. So on number 12, here is the quadratic they give you. 3x plus 10x minus 8. So option 1 was 3x plus 2 and x minus 4. Well, we can use this and just do the box method. And we can just kind of do the box method for each one if you got really good at the box method and see which one is our answer. So I'm going to do 3x plus 2 and then x minus 4. Remember, you can put a 1 there if you need to. 3 times 1 is 3, and I have my x squared. 1 times 2 is 2, and I have my x. 3 times negative 4 is negative 12x. And negative 4 times positive 2 is negative 8. And there's a lot of negatives and stuff going on. That's why just use your calculator. If you're not very good with adding and subtracting negatives, use your calculator. Even the phone calculators have the positive and negatives. Okay, so I'm going to do the same thing. I'm going to add this one. So I have 3x squared. Negative 12 plus 2 is not positive 10. It's negative 10x minus 8. This has negative 10. Your question has a positive. So option 1 is not an option. And then you can go through option 2, option 3, option 4, use the box method and figure out which one comes out to be that. Okay, I hope that was helpful. I keep saying it throughout all these videos. If you need help, please let me know. We can always do one-on-one Zooms, or if there's a couple y'all having the same problems, we can just do like a little small group one, just as long as y'all are getting, being able to get this done. All right, I hope y'all have a great rest of your week. We do really miss you guys, but it is what it is. What can you do? Well, not peace out. All right, bye-bye, guys.